It is exactly 1 o'clock a.m. Pacific time on Saturday, December 8th, and you're looking at a live view of the SpaceX Dragon spacecraft coasting through space as it prepares to rendezvous with the International Space Station about 30 minutes from now. My name is Tom Perderio, and I'm a firmware engineer here at SpaceX. Joining me on this early morning is NASA Public Affairs Officer Dan Hewitt. Dan, thanks so much for joining us today.
Tom, thanks so much for having me. This is my first time hosting a cargo resupply mission from SpaceX headquarters out here in Hawthorne. I'm super excited to be here. Kind of one of the coolest parts of my job supporting the space station is traveling to locations all across the globe where the action's taking place, and it's a privilege to add SpaceX headquarters to the list.
In case you missed it, Dragon launched aboard a SpaceX Falcon 9 rocket earlier this week on Wednesday, December 5th at 1:16 p.m. Eastern. Immediately after Dragon separated from the Falcon 9, it began a series of burns, which gradually raised its orbit to align more closely with the International Space Station. Dragon then received the all-clear to start its careful approach towards that station.
And this approach actually occurs in several phases, and we'll explain why that happens throughout the broadcast today. The first approach point was when it was just 350 meters away from the International Space Station. It's already passed that and moved in much closer. Once that all clear was given, it moved into 250 meters, which is where it's sitting right now at this very moment. So it's just 250 meters away from the space station. That's about 820 feet, or about the same distance as 2.5 football fields. Pretty soon it's going to get given the all clear, and it's going to depart that 250 meter hold point and enter what we call the keep out sphere, which is an imaginary sphere around the space station with a radius of about 200 meters. And this is just in place to put a big set of rules for any vehicles traveling to or from the International Space Station. There's the keep out sphere. There's also something known as the approach ellipsoid, which is much larger. But again, these are just in place for any time a vehicle's traveling to the space station. There's a bunch of gates and a bunch of checks that it has to go through before it actually gets in close for the grapple or the docking or whatever the vehicle is going to be doing. But there's a series of go, no-go polls throughout this that we're going to be listening to and giving you updates as Dragon gets closer into that final capture point.
Right now on your screen, you can see a video as it appears from the International Space Station looking at the Dragon spacecraft. Right now, we just passed into nighttime aboard the station, meaning that the station and the Dragon are currently in the Earth's shadow. So we can't see too much right now on that camera. You can see that strobe light blinking. That is the Dragon right there as it approaches the 200-meter keep-out sphere. For this perspective from the station, it does look like Dragon is kind of stationary or motionless, but it's actually traveling at an enormous velocity as it awaits clearance to proceed to the next arrival checkpoint. Right now, both Dragon and the station are traveling at 17,000 miles per hour, which is insanely fast. A commercial aircraft only travels about 550 miles per hour. And if you were able to fly as fast as Dragon, you could cover the distance from New York to LA in 8.5 minutes.
And we just heard the word that Dragon just got the go to move into that keep out sphere, so it's going to depart that 250 meter point. It's been holding there for a couple of minutes, and again, it gets to these hold points, and the teams here at Hawthorne are just running a series of checks on Dragon, making sure the systems are behaving themselves, and then once everything looks good, they get the green light, and then they give Dragon the go. So control can actually be, or commands can actually be sent from the crew on board the International Space Station. They have a control panel where they can command Dragon to approach, abort, any number of different things, and they're also going to be in the driver's seat for the actual capture this morning. You're going to be hearing a couple of voices today on the space to grounds, as they're called. You just might have heard Serena Anand Chancellor. She's a NASA astronaut on board. She's going to be backing up the prime for today's operations. That's Alexander Gerst. He's a European astronaut, and he's the current commander on board the International Space Station. He's actually going to be using the controls inside to reach out and grab the Dragon. And this view on your screen was actually exactly the same camera and the same screen that they're looking at. It's almost like a video game control for them. They have a joystick and some hand controls, and they're going to use it to control the massive Canadarm2. It's a 57-foot-long arm to reach out and literally just snag Dragon out of the sky.
It is pretty cool how they do that. They're sitting usually inside the cupola on the space station, which kind of looks like the window of a TIE fighter. One of the coolest places to see pictures from the ISS. Right now, like Dan said, you are seeing a view from the ISS. Just a few minutes ago, when the station and the Dragon were in broad daylight, we were seeing some unbelievable pictures because the station, because in that orbit, you get about approximately a sunrise and a sunset every 45 minutes. We'll be seeing hopefully come into light pretty soon. We'll get some nice views of that Dragon. But right now, you can still see the strobe light as the Dragon slowly approaches into that keep-out sphere.
Yeah, it looks like we're about 23 minutes away from sunrise, so we'll be, I mean, we might have some sunrise on the Dragon by then. It's been moving through the checkpoints very quickly today. Team's not tracking any issues with the vehicle, and actually pretty well ahead of schedule. I think the original capture time was supposed to be around 3 a.m. Pacific time over here on the West Coast, but they are at least right now about 30 minutes ahead. So Dragon proceeding smoothly towards the International Space Station. Right now, both vehicles flying over the North Pacific Ocean. They're just about 250 statute miles over the Earth's surface, traveling in this orbital nighttime.
It's important to note that unlike a launch, when the countdown is usually set at a specific time and then all events happen in relation to that launch time at a very fixed schedule, a Dragon approaching capture, or any approaching capture for a visiting spacecraft, is a little bit more fluid than that. The computer aboard the Dragon and the crew on board the station and down here on the Earth are all adjusting to things that happen in real time. And sometimes the orbital mechanics or the slight variations in thrusts from the Dragon spacecraft or the position of the station can cause things to move a little bit faster or slower. So it kind of happens as it happens, and the crews on the ground here make that call of whether or not we're good to proceed.
Yep. Yeah, and we have pretty much a whole window. The window will actually open up in just under 30 minutes, and it's about an hour-and-a-half window where the crew has the go, basically, if everything's behaving with Dragon and everything looks good on the robotic arm, to actually reach out and grapple that vehicle once it's only about 10 meters away. So right now, we're past the 250-meter point, so any second they should be passing through that keep-out sphere. Again, that's just an imaginary sphere around the space station. The next point where Dragon's going to hold is at 30 meters, so it's going to be flying in real close now. We're going to see it get closer and closer, bigger and bigger in your camera screen, obviously, as it continues to approach. And once it hits 30 meters, it's going to do the same thing we just did at 250, and before that at 350. It'll kind of park there, make sure all the systems on Dragon are good, and then once everything again gets the green light, they'll proceed in a little bit closer, and then they'll get to that final hold point, which is just 10 meters or about 30 feet away from the International Space Station.
To give you a size reference on how big that keep-out sphere is that we're now approaching, it's about the size of the Eiffel Tower as the radius of a sphere all the way around the ISS. So you can imagine a giant sphere about the size of the Eiffel Tower. It's pretty big, but in terms of space, in terms of the orbital mechanics, it's not that far away.
Yeah, distances in space are incredibly deceiving. I mean, the International Space Station and Dragon right now are traveling at 17,000 plus miles per hour. And Dragon just, within the last couple of hours has closed the gap tremendously to catch up to the International Space Station. Distances are very deceiving whenever you kind of look out the window, especially if they're in that cupola module. The astronauts can see for hundreds of miles in every direction and around the Earth's surface. And they're flying over it so quick. I think they cover a little over 90% of all the inhabited area on the Earth at some point or another during their orbits around the globe. So it's a fantastic outpost for not only looking back down at Earth, but also for looking out at the universe beyond. And it's just 250 miles above us, which is relatively close. You think about, your average car trip, that's 250 miles, that's a pretty short road trip. But actually getting 250 miles straight up, that's a much more difficult task.
And that's kind of where the orbital mechanics plays in, is to get to the International Space Station, it's only 250 miles straight up, but you can't just go straight up there. Well, you could, but you'd just fall right back down again because of Earth's gravity. Getting into orbit is a little bit more complicated than that. We usually use something called the Newton's cannonball analogy to kind of explain why things stay up in orbit. You can imagine a cannon on top of a tall mountain, and if you shot a cannonball out of that at an average cannonball speed, you can imagine that cannonball just kind of falling back down to the Earth in an arc. If you fired it faster, it would go further and further and further. In fact, if you fired it as fast as you could over the horizon, it would kind of curve around the Earth and eventually hit. But if you could fire it exactly 17 or just about 17,000 miles per hour, it would go so fast, it would go past the horizon and continually fall all the way around the Earth, never actually hitting. And that's really what being in orbit is. It's just falling so fast that you never actually hit the Earth. And that's what the Dragon and the ISS are doing right now.
And that's why anytime you see astronauts on board the International Space Station, they're enjoying microgravity. And it's literally just because they're falling. They're constantly in free fall. You can mimic that same feeling, that same kind of phenomenon here on Earth if you do a parabolic flight on an airplane. Some people call it the vomit comet. It's a very famous airplane where you can actually get that microgravity experience. But the thing about the space station that makes it unique is you're getting that for constantly. So you're able to do research in an environment completely alien to what we do here on Earth. You're able to do experiments where you can take gravity completely out of the equation. It also makes moving big things around like spacecraft a whole lot easier.
And we've had a constant human presence in that space station for almost 18 years now, which is mind-blowing when you think about it. When I was in high school, this thing, they had barely finished the first expedition and built the truss, and now here we are with a continual human presence in space, thanks to the International Space Station.
Keep-out sphere. You now have the authority to issue an abort if no comm with MCCH and light is outside of the corridor.
Copy, Houston.
And again, the voice you heard just there is NASA astronaut Serena Auñón-Chancellor. She's the backup, or in the backup position for today's grapple, and she's assisting Alexander Gerst, who's actually going to be at the controls. So she's handling all the voice communications. She was just talking to the Capcom over in Mission Control Houston, over at the Johnson Space Center, my home base, where it's actually a little bit later in the day for them.
Almost the morning.
Yeah, it's almost the morning for them. It's still Friday night for us here out at Hawthorne. But you're going to hear her voice kind of throughout the procedures today. And again, the crew kind of in the driver's seat for all of these operations this morning. They're going to be the ones reaching out with that robotic arm and grappling the Dragon spacecraft once it's only 10 meters away. Once that's done, though, they actually hand control back down to the ground. And you can see those ground controllers in your screen right now. That's, again, the International Space Station Flight Control Room out in Houston. Once they grapple the spacecraft, they're done. They're kind of done for the day. They hand over control to the ground, who do the much slower process of actually swinging Dragon around to berth it or attach it to the International Space Station. That usually takes about a couple of hours following a grapple, and then they get it bolted in place where it stays for the duration until it's time to come home.
And when we talk about berthing, it's a little bit different than docking, which some other vehicles do to the International Space Station. This actually goes back to old shipping days when you had a harbor with big ships and small ships coming in and out. Smaller, more maneuverable ships that were able to power themselves all the way into the harbor and then brush right up against the dock. That was called docking. However, larger ships that didn't have the flexibility and agility to move inside a harbor were met by tugboats out in the open ocean and brought into the harbor so they could be safely berthed. And that's what's happening to the Dragon spacecraft right now. It's being berthed by the tugboat of the station, which is that 57-foot Canadarm boom.
Yeah, and with berthing and docking, there's some advantages and disadvantages both ways. Most of the cargo vehicles that currently travel to the International Space Station use that berthing method. One of the big advantages is you get a much larger port to move cargo in and out of. They get to use that common berthing mechanism, which is actually the exact same mechanism connecting all of the modules together. It's a great big wide hatchway, which is perfect if you're bringing up great big large bags of cargo or even rack telephone booth size items to the International Space Station.
Docking, however, has its own advantages in that the spacecraft is totally in control of its own approach and its attachment to the ISS. But this does require a more complicated ring mechanism to actually attach to the ISS, so the opening isn't as big. But usually crewed vehicles use a docking maneuver so that there doesn't have to be anyone inside the space station to approach or leave.
Yeah, it's like, look, no hands.
You can see that Dragon solar array right there. It's currently being illuminated by a light, and of course you can see the strobe at the very top of that Dragon. Not much else is visible. Again, we are in the Earth's shadow right now, but The Dragon is currently using a suite of sensors on board in order to track and make sure that it's recording its distance properly or measuring its distance properly to the ISS. One of those sensors is a thermal camera that measures the infrared signal from the space station, and that space station is actually pretty hot when you compare it towards the backdrop of space. Space is ice cold, and the space station is very hot. So when you look at it through an infrared camera, it's just a bright white light. Very easy for the flight computer on board that Dragon to track it and lock on. It's also using something called LiDAR, which is light detection and ranging. This is actually a laser that fires little pulses of laser light towards the station, which are then reflected by retroreflectors on the station. And the Dragon flight computer can measure the time of flight of that laser light back and forth and know exactly how far away it is.
Tom, I'm just proud of you for nailing that LiDAR acronym. And yeah, space station, it's so hot right now. But Dragon's just continuing to approach. Again, we're inside that keep out sphere. The next major milestone we're going to be looking out for is when it's just 30 meters away. So just kind of continue to follow along. Every single visiting vehicle takes this kind of phased approach to the space station where they stop at all these gates. Again, just for teams to run quick checks on the vehicle and its performance as it's approaching the space station. When it comes to bringing two spacecraft together, I mean, these great big massive complex machines, slow and steady always wins the race, whether you're berthing or docking a spacecraft, because it requires a great deal of precision just to make sure everything goes according to plan. We're keeping the spacecraft safe, and most importantly, we're keeping the crew safe.
Station on 2 for Block Bravo.
Where are they on 2?
All right, we see the view starting to converge on monitor 1, camera 03. It's about 3 widths port, maybe about half a vehicle width forward, and camera 9 is centered up.
All right, copy that. Thanks. Nominal performance.
And so as you just heard from that little quick exchange from Serena on Chancellor and the Capcom down in Houston, they have an overlay graphic on the screen that we're getting a couple of camera views of every once in a while, this one right here. And there's an expected kind of approach of where Dragon should line up with some of the square and the circle in the middle of that overlay graphic. And so the crew members are periodically calling out what they're seeing. They have a camera set up that we're looking at right now, so teams on the ground can also monitor in just right alongside them. But she's making these call outs, and then they're going to check where Dragon's expected to be down on the ground. They're able to do that really quickly. There's somebody named a visiting vehicle officer in Mission Control Houston who then gets on the flight director loop and lets the flight director know the status of what the crew just relayed back. And as you just heard Serena call down, she gave the alignment of Dragon right now, and within just a couple of moments the visiting vehicle officer confirmed it was good, and Dragon continues to fly in even closer. The crew does have a control panel on board the space station where they can send commands to Dragon if they need to give it a command to approach or abort any of the above during these final phases of Dragon flying towards the space station.
It's tough to see from this point of view right now, but Dragon does have its solar arrays extended. Right now it's obviously in the shadow of the Earth and there's no solar energy being harvested, but the arrays together with the batteries on board Dragon allow it to just kind of hang out in space. So if there is an abort for any reason, or we need to hold for any problems or anything we see in telemetry, Dragon can just hang out for a little bit. It's sort of a slow and steady wins the race mentality here for these visiting vehicles.
Yeah, and we have that, again, that big capture window. So we have about an hour-and-a-half long block where Dragon will be, if it's at that capture point, the conditions are right, and they can actually reach out and capture Dragon. And that's just the first one. There's another one right on top of it about 5 minutes after this capture window ends. So a lot of opportunities to grapple Dragon this morning, but everything's going really smoothly so far with the spacecraft. They're actually pretty ahead on the timeline still. And it looks like they might get it there early. I think they know that they have some holiday gifts on board, and they're eager to get it there to the International Space Station.
Dragon is currently adjusting its position with its Draco thrusters. It has 16 of those Draco thrusters total, grouped into redundant sets of 4. Those are located all around the side of it. That Dragon, though it launches with the trunk on top of that Falcon 9 in kind of a forward-pointing orientation, it actually is capable with those 16 Draco thrusters of moving in any direction. The onboard Dragon flight computer uses algorithms to figure out exactly which thrusters to fire. And if we get some sunlight, we might actually see those thrusters firing. But of course, as we have been saying, it's a slow and steady operation. Those maneuvers are very calculated ahead of time, and there's no rush. So Dragon is slowly getting closer and closer to its target, which you can see right in the middle of your screen right here. That light is getting closer to the crosshairs, so it can get lined up for grapple.
And we are right about 12 minutes away from sunrise, so we will be getting some light on Dragon in the not too distant future. So we should have some pretty good views of it once it's actually time for grapple. Again, if you're just joining us, Dragon is approaching the next hold point at 30 meters away from the space station. This will be the second to last one. It's moved through all of these different gates, and we're actually just hearing it's inside 100 meters, so it's less than 100 meters away from the space station. It's just about 300 feet. It's going to continue flying in until it's just 30 meters away. And then it's going to pause, and we'll do all the quick checks again. And then they'll get the go to move in even closer. And again, the final hold point will come when it's just 10 meters away, and that's when it's actually close enough for the Canadarm to reach out and grab it. And that's all done by controls with the crew on board the International Space Station, specifically Alex Gerst, the current station commander, is the one who's going to be driving the train today. And he'll actually reach out and grapple the Dragon on a very specific point, a grapple fixture on the vehicle. And once the arm has that initial contact, a series of snares kind of draw the vehicle in, and then it has a firm hold on the Dragon spacecraft.
Currently, that Dragon is using its Draco thrusters to maintain a strict attitude and position, but when it gets close enough to be grappled, we enter what's called a free drift state. That means that we just turn off those algorithms that hold it at a very precise attitude, and then let that Canadarm grab onto those snares. The reason we do this is so that the Dragon's thrusters don't try and fight the snares, and it can be a smooth capture.
And again, once Dragon's captured today, control will actually get handed over to the folks on the ground over in Houston to attach Dragon to the space station. They'll kind of flip it around and then orient it to the Earth-facing side of the space station. It docks to the bottom of what's known as the Harmony module, also known as Node 2. And then once that's in place, it's up to the crew again. They actually outfit what's known as the vestibule, so kind of the space between the Dragon and the station hatches, and then they get ready to open. The hatches are supposed to get open tomorrow morning, but it's not uncommon for the crew to get a little bit ahead of schedule and get the hatch opened, especially when a new vehicle gets there. This Dragon spacecraft delivering 5,600 pounds of cargo to the International Space Station. That takes the form of everything from some supplies for the crew, whether it's some fresh food, which these vehicles kind of the only fresh food that they get while they're on board the International Space Station, but also carrying tons of science on board. These vehicles are literally the lifeline to keep all of that research going on board the International Space Station, and bringing up research, everything from teaching us how to live and work in space for long durations of time, to research being developed by different commercial companies, academics, other government organizations down here on planet Earth that are looking to benefit those of us still down here, and that all flying through the U.S. National Laboratory on board the space station.
Dan and I were speculating that the fresh food was the reason that we are a little bit ahead of schedule tonight.
That's exactly why they're flying right in. They heard there's candied yams and the other food on board, and they're ready to get that out.
It really, like, being up in space is a sort of a challenge in preparation for any visiting vehicle and any crew aboard the ISS. Really, it's sort of like going camping, but you have to bring literally everything with you. You may go camping and depend on something as simple as air and water being there when you get there, but space doesn't really have any of that stuff. So the station really is dependent on all the visiting vehicles to bring up all of the essentials for life. This includes air, water, and food, but also spare parts. The visiting vehicles also can sometimes impart momentum to the International Space Station to keep it in the correct orbit above the Earth.
Yeah, this vehicle in particular actually is bringing up some air for the crew. It's flying 2 oxygen tanks. They're what's known as NORS tanks, nitrogen oxygen recharge system. They're these large tanks that carry up liquefied either oxygen or nitrogen. So super dense liquefied versions of that. This one has 2 oxygen tanks, and that's just to continually replenish that actual breathing atmosphere on board the space station. A lot of the life support systems on station are designed to basically recycle what you have up there. So since you have to bring everything with you, it makes life a lot easier if you can just keep using it over and over again. So everything from the air to the water, we recycle a lot of it. The water is one that always kind of blows people's minds. We like to say that the astronauts, for them, today's coffee was yesterday's coffee, because they're actually recycling everything, all of their urine, sweat, just condensation in the air, all of that gets fed into a recycling system, and we're actually able to reclaim in excess of 90% of all of the water on board the space station. And that's really good. That's, I mean, miles ahead of where we were even in terms of technology at the beginning of the space station, but that has to get even better before we can go to a place like Mars, where you know, everything has to be more reliable, and every pound you bring up is precious. So the more you can recycle, the much better of a mission structure you'll have, and that's where the International Space Station comes in for us. We're developing all of these technologies, we're testing them right now for extremely long periods of time. We're shaking everything out and making sure it works and building the new stuff so we can start sending people even further than we've ever gone before.
Having a continuous human presence in space is critical for those long duration missions that are coming up, especially as we look onto Mars, into returning to the moon, and even other planets in the solar system, other bodies in the solar system. That research that the ISS is doing right now is critical to advancing those technologies, so we're ready for those long voyages.
There's actually a really interesting payload in Dragon's trunk that's coming up on this. It's called the Robotic Refueling Mission 3. This is the 3rd phase of this. It's been ongoing for a while, and it's a NASA payload that's testing just that refueling, specifically refueling of spacecraft and satellites while they're in space. The first 2 phases went through a lot of different tests with new equipment, because they're building totally specialized tools. And one of the cool things that they're trying to do is actually design it so you can refuel spacecraft and satellites that were never designed to be refueled in the first place. The interesting thing with this one that's coming up on CRS-16 is this will be the first time they're actually going to be transferring cryogenic fluid, which is essentially what a lot of rocket fuel is, to a device on board the space station. So that'll be a really exciting milestone for them. They're also going to be actually storing some of that cryogenic fluid, about 42 liters of it, for 6 months. And it's tough to keep stuff cryogenic, because fuel likes to just kind of boil off as it kind of heats up. And so it takes power and energy to keep it cold and to kind of maintain that fuel. So that's one of the things it'll be doing. But that has big implications for everything from just refueling satellites around our planet to refueling spacecraft around the moon on their way to Mars, all of the above.
Refueling here on Earth is pretty simple because we have the ability to utilize gravity to move those liquids around. When you fuel up your car, you're just kind of letting the gas be taken down into the tank by gravity. And then even more critically, once it's in the tank, it's pulled to the bottom where it's pulled into the engine by gravity. Don't really have to think about where the fluid is in the trunk. It's all taken care of for you, or in the tank, excuse me. But in space, in a zero-G environment, that fluid just tends to float around within the tank. Yeah. It's a challenging engineering problem to make it such that the fluid gets to a place where it can be used properly by the engines. A lot of times for rockets, we'll spin the rocket in order to get the fuel all the way around the side, or the second stage of the Falcon 9 rocket actually uses its cold gas thrusters to accelerate the entire second stage just a little bit so that all the fluid is forced towards the back of the tank and can then be ingested by the turbo pumps. So these are all important engineering problems that need to be solved for in-flight refueling on longer missions.
And just a quick status update. We're getting closer and closer again. Our next hold point is going to be at 30 meters. Right now, they're about 68 meters away from the space station. So just continuing to close in. If you're just now joining us, we're well ahead on the timeline today for the grapple. Dragon's closing in on that 30-meter hold point, which will be its next kind of pause, where it'll camp out. We'll run some checks here in Hawthorne, just make sure all the systems are still good, and then they'll go to move into that final capture point. The capture point is just 10 meters away from the space station, and then it's over to the crew on board. And it's going to be Alex Gers, the European Space Agency astronaut and the current Expedition 57 commander, who's going to be at the controls today. And he's backed up by Serena Auñón-Chancellor, a NASA astronaut. We'll hear her voice periodically coming over those space-to-ground loops, talking to the teams down in Houston.
For those of you just joining us, Dragon has been in the Earth's shadow for the majority of our webcast today, but it looks like sunrise is only about a minute and a half away. So hopefully we'll get some nice sunlight views of Dragon as it gets closer and closer to the International Space Station.
Yeah, we should have some great lighting conditions for that actual grapple, so it's always cool to see Dragon just kind of flying there real close to the space station, the clouds or the ocean or wherever we're flying over, flying down below as both vehicles are traveling in excess of 17,000 miles an hour. It kind of gives you a holistic view of everything taking place, and it's always pretty mind-blowing to see two spacecraft that just a couple of days ago, one was on the ground, one was flying, a few hundred miles above. All of a sudden, they're right next to each other. It's always incredible. It's always very humbling to see this stuff happen. But it's been slow and steady so far. It's actually been ahead of schedule so far. We were originally expecting to grapple around 3 a.m. Pacific time, but they've been about 30 minutes or so ahead. Not tracking any issues with the vehicle. The teams in Houston on the left there and Hawthorne on the right working in tandem for all of these operations this morning as Dragon just gets closer and closer. We're still waiting for it to arrive at that 30-meter point, which will be our next hold. That should be there within the next couple of minutes or so.
On your screen right now, you can see. You just did see those two mission control centers, one inside NASA headquarters and one at SpaceX headquarters. And there is a view of the Dragon finally coming into the sun. This is a view from the end of the Canadarm as it looks towards the Dragon. Just describing what you can see, that those are the Dragon's solar arrays on the side of the trunk, and right in the center of the pressurized capsule is the avionics bay. It's that dark spot in the middle of the Dragon capsule. That is actually the inside of the door that opened up to expose those sensors is where the grapple point is, so that camera view will get closer and closer to the Dragon on that point. But those guys at NASA headquarters are there 24/7 usually, supporting all the human activities aboard the space station.
Yeah, at the Johnson Space Center, in that room, you have people 24 hours a day, 365 days a year, and that's been the case in that room for a little over 18 years now. As long as there have been people on board the International Space Station, which the first ones showed up in November of 2000, you've had people on the ground supporting them, because the people in that room are the ones who are actually flying the station right now. I mean, for pretty much every system on board, there's a console in that room controlling it. Everything from which way the solar arrays are pointed to what the temperature is inside the vehicle. They actually control the thermostat at the Ethos console, who does all the life support. And so they're in that room flying the International Space Station, supporting the crew on board, and then working with control centers all around the globe. We have control centers with all of our international partners in Canada, in Europe, in Russia, and in Japan, all supporting their different modules and equipment on board the International Space Station, and then also obviously working in tandem with control centers from our spacecraft providers like SpaceX, like we're doing this morning.
The guys and girls at the SpaceX Command Center are not there 24/7, but whenever a Dragon spacecraft is in orbit, it is constantly manned, and we always keep track of exactly what the Dragon is doing.
But for now, getting some great daytime now views of the Dragon spacecraft. It's getting closer and closer. Again, slow and steady is the name of the game. Anytime two spacecraft are coming together in orbit, they're going to be just doing these gradual checks. And then once it's time to grapple the vehicle, that view on the left there is actually a camera right at the end of that robotic arm. And we're going to see that hone in right on that grapple fixture on Dragon. And that's going to be under the control of the crew members on board, specifically European astronaut Alexander Gerst, who's going to be controlling the arm today. And we'll be hearing NASA astronaut Serena Aumann-Chancellor on the space-to-ground loops. She's right next to him, backing him up for all of these operations. And then one of the new arrivals on board the space station, NASA astronaut Anne McClain, is also going to be kind of riding side saddle today with the crew. She's just been on board for a couple of days now. It's her first time ever in space. But she's here to help out with today's operations as well. But for all of the crew, once Dragon gets attached, it kind of kicks off a series of fast and furious weeks for them to get all of that cargo unloaded and then load all the cargo back in. Because, I mean, the big thing with Dragon that it provides right now is a capability to deliver thousands of pounds back down to the ground. And that's a great capability for a lot of the researchers who want to get their experiments back as quickly as possible and then do all the processing down on the ground. And it's currently the only cargo vehicle in the station suite of vehicles that has that capability. So once they open up that hatch, it's pretty much no time off for them, where they're busting through a whole bunch of different science experiments that are also going to come back down on the Dragon, taking all the cargo off that's staying and then loading all the cargo back on that's going home.
Dragon is now approaching that 30-meter hold in just about a minute from now.
And there, we'll start seeing some clouds now as now moving over the Terminator line, one of my favorite space terms. That's that line between night and day on the Earth's surface. And you're going to see the clouds start to come into view. The station and Dragon right now flying over the southern Pacific, about to make a swing just over the very southern tip of South America, passing over the mountains of Chile and Argentina.
We're getting a good look at the Dragon spacecraft right now. That door that seems to be open towards the bottom of the pressurized module is the GNC bay door, or the guidance, navigation, and control bay door. That's where all the avionics and sensors of the Dragon are able to see out past the heat shield, or the heat shielding.
And just hearing...
Station Houston on Space to Ground 2 for Dragon.
Go on 2.
All right, the Dragon is at the 30-meter hold. We are performing our assessments on the ground, and we'll let you know shortly when you are go to proceed with step 4 in 1.102.
We are standing by.
All right, well, there's the call to the crew. Dragon now at the 30-meter hold point. So again, it's just going to hang here. They're going to do their assessments on the vehicle, and then the next thing up will be actually moving into the final hold point, and that's also known as the capture point. It'll only be 10 meters away from the space station, so just about 30 feet, and then it'll be within grabbing range of that robotic arm.
The Dragon is right now using its suite of sensors to maintain 30 meters from the ISS. Right now the primary sensor is the LiDAR sensor, light detection and ranging, using those laser pulses to check exactly how far away it is. For attitude control, which is how the spacecraft is pointed, it actually has one of my favorite sensors, the one that I think is one of the coolest sensors on the spacecraft. It's called the Star Tracker. It does exactly what it sounds like. It actually is able to detect constellations out in the blackness of space and make sure that it can see exactly what direction it's pointed.
Hold per step 4 in 1.102, and you are go to maneuver to high hover.
Copy, going into step 4, and we are also go for maneuver to high hover.
So real quick, the go to maneuver to high hover, that's a reference to a maneuver for the station's Canadarm, so that robotic arm. And so they're going to be just moving through the steps to now get the robotic arm ready, as Dragon's just one stop away from that capture point. And it's going to be crew controlled. Alex Gerst, the current station commander, is going to be driving in that robotic arm using controls inside the station. They're kind of like a video game where he's got a joystick and some other hand controls to actually reach out and just snag Dragon out of the air.
Station on 2, prior range 30.49, secondary range 29.99.
And here's the copies.
That Canadarm itself is actually a very impressive piece of technology. 57 feet of robotic arm with multiple joints and end apparatuses. That's it must be fun to operate, whether it's in virtual reality or on the station itself.
Yeah, and I mean, the thing literally built the space station. It was one of the first pieces that went up, and it was used every time a new module or the solar arrays or these giant structures that now comprise the station. It was basically building it piece by piece, block by block. Now it's used for a variety of different operations too. So not just building the space station, it's used to grab visiting spacecraft out of the sky. Some lucky astronauts get to put a foot restraint in it and get flown around during a spacewalk. I don't know if you've seen that, but that looks like kind of the greatest ride and the greatest view, and,
I bet.
you know, on or off the planet. But yeah, very versatile piece of technology. It's going to get used with a special attachment known as Dexter, the special purpose dexterous manipulator robot, to remove those payloads in the trunk of Dragon. There's 2 science experiments that came up in that unpressurized section that are going to get homes outside the space station to do their research. One's that robotic refueling mission number 3. The other one has a much cooler name. It's the JEDI, standing for the Global Ecosystem Dynamics Investigation. That's going to be doing some laser ranging observations of the Earth's forests, specifically looking at kind of how much carbon is stored in vegetation down on the Earth.
You can see a beautiful shot from the International Space Station, including the curvature of the Earth, looking towards that Dragon spacecraft free-floating, or not free-floating yet, but holding position at about 30 meters while the Canadarm extends and gets into position.
Yeah, right now they're working to finish configuring that robotic arm. Once it's in the right position, it sounds like we'll be just about ready to depart this 30-meter point and then just fly into that final hold point, the capture point, at just 10 meters away. Yeah, this is a great view. There's a number of cameras on the outside of the International Space Station, some in HD nowadays, some in SD. This, again, if you're just joining us, that was a camera on the end of the robotic arm, but here's a great HD shot of Dragon looking right down at the Earth below.
The ISS and the Dragon are currently flying over the tip of South America. Looks a little cloudy down there right now, so we can't see any land features, but we might be able to see some as it gets to less cloudy portions of the globe. Dragon does carry science and payloads on both the pressurized section of the capsule and the unpressurized trunk that Dan was talking about. The reason we do this is because while the station does have airlocks on it, they're not exactly the largest openings in the space station. So if we have large experiments that are easier to just take up in the vacuum of space, it's easier to use that Canadarm to just grab them right out of the unpressurized section of the trunk and mount them on the external surfaces of the space station. But of course, for pressurized cargo, it's much easier to have it already in an atmosphere that's good for humans. So the astronauts on board the space station, once they open that hatch, will actually go inside the Dragon spacecraft and start moving that equipment and supplies into the environment of the ISS.
And we talked a little bit about the two payloads in the trunk right now, and it's going to be looking at refueling spacecraft while they're in orbit and also studying the Earth below. Some of the external payloads that are sitting outside the space station right now are just kind of mind-blowing in all of the different fields of science that they're looking at. I mean, you have stuff obviously monitoring the Earth below the station, a great vantage point to look back at the Earth and study everything from wind speeds to climate change and things of that nature. But we also have payloads actually on the space station right now looking way out beyond. You have things like the alpha magnetic spectrometer, which was delivered on one of the final shuttle missions looking for the signs of dark matter and the origins of the universe. And there's another payload that was one of my favorites that Dragon delivered that's actually looking at different stars throughout the galaxy and is actually developing a means to use specific stars known as pulsars. So stars that emit giant visible or in different wavelengths of radiation, and they're actually trying to develop a means to use these pulsars to develop basically an interstellar navigation system. So I mean, this is something that's just so forward-reaching, it's unreal to think about that. Like, that is up there right now, mapping the cosmos for us to eventually, you know, fly around in. So it's just really cool that that research is taking place right now.
Those pulsars are like the lighthouses of the universe, sort of just constantly emitting their own signature. And definitely would be almost science fiction-like to have a universal navigation system based on that.
Yeah, but for right now, still holding at that 30-meter point. Again, we are pretty far ahead of on the timeline today. We actually weren't supposed to be here for about another 30 minutes or so. So everything going really smoothly today with the operations, with Dragon's approach to the space station. This is the last hold point before we get to the capture point, and that's when the action kind of kicks up a bit and the crew gets the go to reach out and grab Dragon and get it in that initial grapple. Again, this is a view right down the robotic arm. It's going to hit the grapple point on the Dragon spacecraft, which you'll see come well into view once that arm gets much closer. It'll get that initial grasp, and then a series of snares will kind of pull it tight, and it'll have a firm hold on the Dragon spacecraft. And then the crew gets to hand over to the ground to do the much longer task of actually maneuvering it and bolting it to the space station. That typically takes a couple of hours. But they'll get that done entirely from the room down there in Houston. So that's always kind of surreal to think about too. You're sitting in a room in Houston commanding an arm on a spacecraft potentially thousands of miles away from you.
Moving at 17,000 miles per hour.
Moving a giant spacecraft that it's attached to. So it's pretty crazy what these flight controllers are able to do and what we're really able to do in space today. All right, and you're seeing some motion. This is the arm now going into what's known as that high hover position. So this will be one of the final positions that they have to move the Canadarm 2 robotic arm to before it's ready and configured for the Dragon to begin its final approach.
Dragon and the ISS currently moving out into the open ocean of the southern Atlantic. Looks like the cloud cover is thinning out just a little bit. Like Dan was saying earlier, the orbit of the International Space Station brings it into view of almost 90%, I believe, of the habitable area of the planet, which is really exciting. I can't even imagine what that view is like from the cupola.
And that actually reminds me, you can actually see the International Space Station with your naked eye from the ground. If you actually go online and head over to Spot the Station, you can put in your town, wherever you are, anywhere over the globe, and you can see sighting opportunities. So opportunities where you can look up into the night sky. It typically is best done either in the very early morning hours or in the kind of the late evening hours, and you can see the International Space Station flying across the sky. It's brighter than any star in the sky when you can see it, and it moves much faster than an airplane or anything else you're used to seeing. Believe me, when you see it, you know you're looking at it.
By far the largest object in space.
Yes, the largest man-made object in space right now.
That's
the
true.
Station,
Man-made object.
Man-made
yes.
object in space. Tipping the scales right at about 1 million pounds or so. And if you put it down on the ground, it basically cover a football field from end zone to end zone. And I mean, this thing was built piece by piece. So you have all of these different modules. We just actually celebrated the 20th anniversary of the very first module. That was the Zarya module over on the Russian segment. It launched back in November of 1998. And it's been up there every single day since, and we built on piece by piece to now get this giant space station that we have. The interior volume roughly of a 747, 6 people living and working every single day on board. Living quarters, experiment hardware, exercise equipment, everything's on board.
And those modules don't just stay up there all by them. Well, they orbit the Earth, but they actually do enter a little bit of drag over the years. Molecules that are really high up in the atmosphere, even though there really isn't much atmosphere up there, even a little bit like an oxygen molecule here and there at 17,000 miles an hour over the course of many, many orbits does sap away from the momentum, the orbital speed of the International Space Station. And it's a little bit more of a problem for the ISS with all that big surface area than it would be a normal satellite or a spacecraft. And for orbital mechanics, whenever you slow down, you also fall down closer to the center of your orbit. In order to keep the International Space Station exactly where we want it in the orbit, it has to be periodically raised up in raising maneuvers. And this can be accomplished by either visiting vehicles or one of the engines on the International Space Station itself. A lot of times visiting vehicles will carry fuel up to the ISS in order to perform those maneuvers.
Yep. The primary vehicle that we'll use for those reboosts is the Russian Progress spacecraft. It's very similar to the Russian Soyuz, which currently carries crew to and from the space station, except it just carries cargo. It looks very similar. There's some slight differences in the outside that you can kind of tell them apart, but it's one of the main sources of fuel for the space station. They actually use it for those reboosts.
SSRMS is in the high hover position.
Here's a copy.
All right, and just there, NASA astronaut Serena Anand Chancellor confirming the Canadarm2's in that high hover position, so you can see it's kind of swung around, and now it's looking straight on to that grapple fixture on the Dragon spacecraft. So with it now in the right position, we should be getting the call momentarily for Dragon to begin its approach one more time from that 30-meter hold point where it's been camping out, and then it's going to move into the capture point just 10 meters away. We're so close.
You can really see the details of that Dragon from this angle on the end of the Canadarm. This camera is about to get very familiar with that dark spot right in the middle of the Dragon. That's the inside of that GNC bay door. The reason that the grapple point is on the inside of the door is the outside of the Dragon spacecraft is exposed to the atmosphere during a launch. The Dragon doesn't have a fairing on the outside, so the exterior surface needs to be pretty clear of any obstacles, anything that would produce uneven drag. And that capture snare is designed essentially for drag, mechanical drag on the end of the arm. So what we do is we keep that capture point on the inside of the door, and the door opens up, flips around, and then locks in position so the Dragon can be manipulated. And we'll get a little closer and more detailed view of that as the arm gets closer. This particular Dragon spacecraft, this is not the first time it has visited the International Space Station. This is a reused Dragon. It originally visited the station back in February of 2017 during the CRS-16 mission. So it's not the first time around for this particular spacecraft.
Continuing to enjoy these views, though. Again, we're still just holding at that 30-meter point. We're just waiting for a couple of more boxes to get checked, and then they're going to get the go to begin flying Dragon in even closer, and it's going to get to that final hold point at just 10 meters away, or just about 30 feet. And then it's all in the hands of the crew on board. Alex Gerst at the controls of the robotic arm. He's going to slowly reach out and maneuver it so it reaches to that grapple point on the Dragon spacecraft. They'll make an initial contact and capture, and then we'll consider the vehicle captured. And then they'll engage a series of snares on the very end of the arm. You might hear it called the Lee. It's the latching end effector. It's basically the hand of the robotic arm, and that's what they're going to be using to attach to the Dragon spacecraft this morning.
You really have to admire how it looks like the Dragon is totally motionless with respect to the space station. And all the engineering and programming and the flight computer autonomously acting on the Dragon right now, and the International Space Station and the crew on the ISS, to bring these two objects, again, like you said earlier, one that was on the ground just a few days ago, to a point where it looks like it's motionless, but still flying at 17,000 miles per hour. All of that is just a tremendous engineering marvel, and it's very humbling to watch in action.
There's a reason I leave the orbital mechanics to the rocket scientists. It's an incredible feat every single time we do it. It's something so hard to grasp sometimes, but I mean, stuff like that view right there never gets old. And so this is really just kind of the start of Dragon's stay at the space station. So once it gets captured, it'll get attached to the Earth-facing side of the Harmony module, and then the crew will work to actually open up the hatch. As we said a little bit earlier, they're supposed to open up the hatch tomorrow, but it's not unusual for the crew to kind of get ahead of their timeline and to move in and open the hatch up early. Packed inside of Dragon, there's thousands of pounds in that pressurized section. There's a little over 670 pounds of just crew supplies. That's everything from food to clothes and just other perishable items for the crew on board. The lion's share of all the cargo on board, though, is science investigations. There's over a ton of science packed on board the spacecraft today. And those experiments are going to be everything from studying things in the medical industry, flown by pharmaceutical companies here on Earth doing research, to a couple of technology demonstrations. There's actually even a small payload inside that's going to be attached to another spacecraft that's going to deploy satellites once that spacecraft leaves. So a lot of stuff inside of Dragon. Once they get the hatch open, they'll have a couple of weeks to unload and actually execute a lot of the science before it gets packed back inside Dragon for the trip home. And then Dragon splashing down in the Pacific, and a lot of those investigations, a lot of those science experiments getting handed over to the investigators right there at the dock when it gets back here in California almost immediately. So a really unique capability every time we have one of these Dragon flights to the space station, and a really important one for all the science taking place on board.
So on the left-hand side of your screen, that's the camera at the very end of that Canadarm, looking at the Dragon. And then on the right-hand side of your screen, you have a view from the Dragon looking back. So you can see the International Space Station's habitable modules right now from the Dragon camera. This is an infrared camera, which is why there's no color. So right now, on an infrared camera, anything that's light means that it's really hot. Anything that's really dark means that it's cold. The ISS is incredibly hot compared to the coldness of space behind it, so it appears very white in that image. That camera is inside that GNC bay door currently open, along with the other sensors that help Dragon keep track of its position and attitude. We're currently wrapping up almost 8 years of Dragon flight. The first Dragon was back in December 8th of 2010, and it's now December of 2018. It's been a long, exciting history of cooperation between SpaceX and NASA, and we're all very proud to see Dragon fly again.
Yeah, time flies. It's hard to believe it's been 8 years, but that's kind of one of the nice things about this is there's always so much going on with the space station. There's always so much going on in space. Time definitely flies by, but this almost feels routine. It's another Dragon, but like it's exciting because it's another Dragon. It's
Dragon too.
Yeah, and it's the spacecraft behind us right now.
We currently at SpaceX headquarters, we have the very first Dragon that flew almost exactly 8 years ago, hanging up in our main lobby as a reminder to how far we've come. You can actually see it right here. That is the very first C1 Dragon behind us. And it's been, yeah, eight whole years to get to where we are today. And again, like I said, this is the second time this particular Dragon has flown, so making real progress. You can still see that Dragon holding at the 30-meter point. Still waiting on the crew to give the go-ahead to come into that 10-meter capture point.
And again, this capture, they'll typically peg to an expected time, but they do have a whole window. The window, about an hour and a half long for this first window, for where they can capture the vehicle between, and then even if they don't hit that window, there's another window right behind it. So plenty of opportunities this morning to grapple with Dragon. But yeah, as Tom just said, we're holding at 30 meters. The next milestone is going to be approaching into 10 meters, at which point it'll be at the capture point. Then we'll see that arm start to close the gap and grapple the Dragon, and then that'll be it for the crew, at least for a couple of hours until the Dragon spacecraft gets attached and they can start getting ready to open up the hatch. And Tom, we're already over Africa. I mean, I feel like the last time we looked at our map, we were just over South America. So yeah, it just gives you kind of the scope of how quickly they're flying over the Earth right now.
One orbit in about 90 minutes in low Earth orbit. Makes for a lot of sunsets and sunrises aboard that space station. As Dan mentioned, we are flying over the western coast of Africa right now. SpaceX has a ground station in Gabon, where we're picking up some of the direct-to-ground video from that space station, or from the Dragon. We also have proximity communications between Dragon and the space station by way of a UHF transmitter called Cuckoo, which I believe stands for Common UHF Communication Unit. This way, that's how the Dragon, that's how the crew members aboard the space station are able to command Dragon, and how we're able to keep a live telemetry link between the two spacecraft.
And way to nail another acronym there, Tom. Yeah, for the space station, where we use a space-based network known as TDRS. It's the Tracking Data and Relay Satellites, and it actually enables us to keep almost constant communication with the space station. You will see video dropouts every once in a while, and that's typically indicative that we're either handing over between one satellite to another, or that somebody else is using that satellite. We're not the only customers using the TDRS satellite, so we do have to share time. But in critical phases like this capture today, or things like spacewalks and things like that, we can get pretty much constant uptime using these space-based satellites to get video and audio communication with the crew on board, and also to do the things like sending commands from Mission Control Houston.
The Dragon 2 spacecraft will actually be capable of talking to the ground, both through direct-to-ground communications, through the TDRS satellites, like you mentioned, and via the station, via those proximity communications that I was talking about earlier. Just an interesting point of trivia. The radio that the Dragon is currently using to communicate with the International Space Station was brought up to the ISS by one of the last shuttle flights. That's the space shuttle paving the way for the future of commercial spaceflight.
That's right. I mean, the space shuttle was responsible for building pretty much the entire space station. Most of these modules were brought up over different dozens of different shuttle missions, and then a number of modules also flying up on Russian rockets. And for the early years of the International Space Station, that's also where you were getting your supplies. They would essentially bring up an entire space station module just packed full of supplies for these supply runs. Once the shuttle retired in 2011, though, we needed to go in a new direction, and that's where companies like SpaceX came into play, where NASA partners with these commercial companies, SpaceX, and also Northrop Grumman, to actually deliver all of these supplies to the International Space Station. So not only are there these vehicles, there's a suite of international vehicles, there's a fleet of spacecraft servicing the International Space Station. Right now, there's only one crew vehicle, that Russian Soyuz, but there's going to be some new crew vehicles coming up in the not too distant future, including a SpaceX Dragon.
In fact, the last American crew on a space shuttle that came up aboard a space shuttle left a flag in the International Space Station to be claimed by the first American crew on an American vessel to visit after the space shuttle. And of course, SpaceX is in competition to hopefully grab that flag.
Yeah, but for now, though, the mission at hand, still holding at this 30-meter point. And pretty soon it'll be moving into that 10-meter hold point, or at that capture point. And we'll be able to actually reach out and grab this Dragon spacecraft. So still standing by, still inside our capture window. And pretty soon we should be getting the call for Dragon to begin departing that 30-meter point and head on towards that capture point. So we'll be getting the video back with station in a little bit. As you saw, we're in something called a handover. And as I talked about a little bit earlier, we have almost constant coverage with the space station. They actually still have S-band, so they can still send commands, but we get all of our video through another wavelength called KU. It's where you get your much higher data rate and you get your video. It could be anything from they're handing over between satellites, but what it actually looks like it might be is something we call blockage. So there's an antenna on the space station that points at the satellites to actually get that KU band, and every once in a while as it's tracking those satellites, it'll get blocked by something like a solar array or some other piece of the space station itself. So just in a couple of minutes we'll get those views of Dragon back, but for now, if you are just joining us, Dragon is holding at the 30-meter point. It's just 30 meters away from the International Space Station. It's been flying there since Wednesday when it took off, and now it's just 30 meters away, so we're almost there. It's going to continue to hold here until the teams are done checking out the Dragon systems and the crew on board, make sure the robotic arm's in a good configuration. And then it's going to move into that 10-meter capture point, and then it's game time. Then it's time to actually reach out and grab this Dragon spacecraft.
At that point, once we get to that 10-meter hold, that Dragon will enter a free drift, and then it'll be free to capture by that Canadarm. And that Canadarm has a kind of a hand at the very end of it, grabs onto the capture point that's on the GNC bay door of the Dragon, and then grabs it while it's in free drift, and then the capture is complete.
Yeah, and then once the crew actually has it captured, and again, it's the crew controlling the arm this morning. So it's Alex Gers, he's the current Expedition 57 commander from the European Space Agency. He's at the controls, and they're kind of like a video game where it's a joystick and some hand controllers, and they're using cameras on board to actually maneuver that arm, and they're going to reach out and grab the Dragon spacecraft. Once they do that, they're done for now, and they actually hand control over to the teams on the ground, which you can see on your screen on the right side here. Those are flight controllers and Mission Control Houston, and they're responsible for monitoring a lot of the systems and controlling a lot of the systems on board the space station, but they're also going to be responsible for actually attaching Dragon to the space station today.
And Dragon is attached by a berthing, which is a little bit different than docking, but berthing actually involves bolting from the inside that Dragon to the common berthing mechanism on the International Space Station. And the reason why Dragon uses the berthing process is because it allows us to have a much larger hatch, so we can bring in much bigger pieces of cargo than for a docking mechanism.
Yeah, it's a little bit slower process, and berthing always requires somebody else to be kind of in the loop. So Dragon arrives, there has to be somebody on board the space station to actually reach out and grab it, and then somebody to attach it. So there always needs to be somebody kind of facilitating the whole process. Whereas with docking, which a lot of your crew vehicles will do, it's a much faster process to not only arrive but also to depart, but it can be kind of all automated. It's almost like hands-off, where you can just arrive and go straight in, and it's all through powered mechanisms to actually dock directly to the space station, and that's what all the crew vehicles are using. And one of the big things is it is a much faster process. So with the actual berthing, you have to bolt them in place and then unbolt them, and that does take quite a bit of time. With a crew vehicle, if you need to get out of there in a hurry, you want to be able to, and that's why they use docking.
And right now, the Soyuz module uses docking. SpaceX's Dragon 2 will also use docking by way of the International Docking Adapter, which was brought up by a SpaceX mission previously. And that International Docking Adapter, again, allows a spacecraft to just approach and then use the mechanisms within the docking mechanism itself to just grab on, and so it allows you to depart in a hurry if you need to, which is important.
Yeah, and that International Docking Adapter is actually on the same module that Dragon's going to get attached to today. It's on Node 2, the Harmony module. It's in a different orientation, though. So Dragon today is going to get attached to the Earth-facing side, also known as the nadir port on the International Space Station. But on the Harmony module on the forward port is that International Docking Adapter. And that used to be the location where the space shuttle docked. But once these new commercial crew vehicles, like the one from SpaceX, start flying, that's going to be their new port of call on that International Docking Adapter. So hasn't been used yet, but it will be very soon.
Oh, we're all very excited for it to be used. Right now, Dragon is approaching on what's called the R bar. That's the vector approaching the International Space Station called the radius bar, and it kind of means that we're coming directly up from the Earth. The radius between the International Space Station and the Earth coming right up towards that the ISS. But Dragon 2, as you said, will be approaching from the forward direction, the V bar. That's the vector in the velocity direction of the space station as it orbits the Earth. So it's a little bit of a different maneuver to get there. and 2 different docking and berthing mechanisms too. Just kind of shows the versatility of the space station, which makes sense given that it's been assembled over so many years and needs to be able to be reconfigured as different needs as time goes on.
Yeah, the first piece of the space station just turned 20 of less than a month ago. Well, about a month ago, the Zarya module, which launched from Baikonur, Kazakhstan, back in 1998. The first humans arrived on board the space station in November of 2000. So any of you watching, if you're under the age of 18, every single day you've been alive, human beings have been living and working in outer space. And like, that is just surreal to me to think about. And the International Space Station is actually about to fly over the Baikonur Cosmodrome in Kazakhstan, where kind of it all began. That's where our Russian colleagues in Roscosmos, all of their rocket launches take off from. And that first launch back in 1998 took off from there as well. But yeah, 20 years of the space station being in orbit. It started out as just kind of one small module, and now it's this sprawling million-pound football-sized spacecraft with 6 humans living on board right now. And humans have been on board for over 18 years. And they're doing everything from research on just how to live in space, because that's important to know if you're going to go to places like back to the moon or onto Mars. You need to know how to live really long durations of time, and the space station is in the perfect location. It's just 250 miles up, relatively close in terms of distances when you start talking about going to space, to learn all of those things.
It's true. Having that the ISS right there in orbit is very useful for communications to and from the ground. Even at the moon, there's several seconds of delay in radio communication to go back and forth from the moon. And at Mars, it's even worse. It can be sometimes up to 20 or 40 minutes round trip at the speed of light just for communications from Earth to get all the way to Mars and then back. So those instantaneous communications that we're hearing, or near instantaneous communications between the Earth and the International Space Station, are essential for conducting that kind of close-in science, and also allow maneuvers like the berthing maneuver that we're about to see. Yeah. Once we're grappled and the ground is actually in control of that Canadarm, bringing it into the common berthing mechanism.
Yeah, the space station, we're developing a lot of these technologies that are going to be necessary to actually send humans way out beyond our local neighborhood, really, what we call low Earth orbit, just within a couple of hundred or even a couple of thousand miles off the Earth's surface. With the space station, we're able to do a lot of things on the ground. So in that room you're looking at on the right, Mission Control Houston, they're actually flying the space station. They're controlling all of the different systems, at least on one entire half of the space station, and working with different control rooms all around the globe, all in tandem, all at the same time, every single hour, every single day. And they're able to do that because the station's still so close. When we start sending people to a place like Mars, though, you lose all of that functionality. You lose that capability because you can't wait 40 minutes round trip to, command something or change anything in the life support, things like that. So we're developing these technologies on the space station, so we'll be able to do those things. Everything from learning how to recycle water and the air on board, to actually learning how to empower crew members to be a little bit more self-sufficient. We'll be doing some tests where we mimic some of those communication delays, but we want to try to empower them through different types of technology to actually have access to repair manuals and other things like that. Is when you're kind of out there millions of miles away from home and it takes 40 minutes just to how are you this morning? Good. Mm-hmm. Having somebody walk you through fixing something as complex as your oxygen generation system won't be feasible. So we're learning how to not only develop those, but learn how to maintain them and empower the crew members to do that on board.
Even the robotic missions that are taking place on Mars right now need to have a high degree of autonomy to be able to make the decisions they need to complete the science objectives. The Mars rovers right now, the Curiosity rover has algorithms built into its computer that allow it to make real-time decisions rather than wait to be commanded from all the way back from Earth. Again, a 40-minute round trip doesn't really help you with long-term science goals. It takes a long time to communicate. So if the controllers on the ground at JPL give it a command to go to that distant objective over there, it then falls in the flight computer of that Curiosity rover to avoid obstacles, drive around rocks, and that's the kind of technology we're going to have to continually develop, and what the science aboard the International Space Station helps us develop as we set our sights on Mars and beyond.
Yeah, and it's kind of surreal to think about, what these automated computers, because Dragon is pretty much flying itself this whole time.
Too, for the robotic camera.
Sounds like they're getting some conversations now with the team in Houston and the crew on board the space station. Should hear. There's Serena on Chancellor.
We were just checking our data down here. We were looking for the camera angles for step 3.2 in the Dragon capture procedure.
I'll be taking a look.
You can even hear that small amount of delay.
Yeah, and again, those voices you're hearing just there. So that's Serena on Chancellor. She's a NASA astronaut. She's currently on board the space station. She's in kind of the backup role for today's operations to actually capture Dragon. She's assisting the current commander, Alex Garce, who's going to be at the controls, but she's doing all the voice communications between the station and that Capcom there in Houston. And we have views back once more from the space station. So we got the KU band, or kind of that high data rate communication link reestablished, so we're able to get this real-time video. This view from the business end of the Canadarm2 looking down at Dragon. Again, just 30 meters away from the space station. It's been holding here. In about 5 minutes, they are going to be going into an orbital sunset. So we're going to see the lighting conditions start to darken on the Dragon spacecraft as they are moving over the nighttime portion of the planet. The station and Dragon flying just to the north of the Mongolian border over Russia at an altitude of about 253 statute miles. You can already see the ground beneath Dragon is dark. They've crossed over that Terminator line, that demarcation between night and day on the Earth's surface. They are a little bit higher up though, so they still have a little bit more sunlight for about 4.5 minutes.
Station on 2, crew ready for Dragon approach to capture point.
Okay, copy that, Serena. So in order to satisfy the lighting constraints for capture, we're looking to depart 30 at 10:42.
Copy, 10:42.
And so you just heard that exchange. So Dragon right now, it's just 30 meters away. When they actually go to capture the vehicle, they do have, you heard them say, lighting constraints. Basically, the lighting conditions for Dragon and the space station need to be in the right configuration or the right setting, so they have a good view of that grapple fixture and everything else. So it sounds like we're going to depart this 30-meter point in just about 12 minutes or so. And then it'll begin flying in a little bit closer, and then it'll get to that capture point, which puts it just 10 meters away from the space station, just about 30 feet, and that'll be its final hold, and then it'll be time to reach out and grab Dragon.
Station Houston on Space Ground 2 for Dragon.
One, two.
All right, Dragon is ready to proceed to the capture point. Expect approach to resume shortly.
Copy, Houston.
And so we just heard the call up to the crew. Dragon is ready to depart that 30-meter capture or that 30-meter hold point. So we've been holding here for a little while. The crew just making sure everything's good to go. All the camera views are in the right configuration. The arm's in a good motion as well. And now Dragon is going to depart. So it's going to start flying in once it gets commanded to the 10-meter capture point.
Station Houston on 2. Dragon has begun approach from 30 meters. Monitor per step 5 and 1.102.
Copy, step 5.
And there we go. Confirmation Dragon now getting closer. It's in motion again.
Well, we did give the command for the Dragon to proceed. It's now going to use its 18 Draco thrusters to get just a little bit closer to the ISS, going from that 30-meter point all the way into the 10-meter point. I mean, 10 meters is not that far, given where it was when we came out on this webcast. It was out of the 250-meter point all the way down to 10. We're just a stone's throw away from the astronauts in the ISS.
Yeah, and so once it gets there, it's gonna hold. It's gonna kind of hover again, but this will be the last point. And then it'll go into what's known as free drift, as Tom was talking about earlier, basically disabling all of its thrusters to just kind of put it freely out there, hovering away from the space station. And then it'll be time for Alex Kursk to command that station robotic arm to reach out and grapple with the Dragon spacecraft. They're going to probably wait until we get better lighting conditions, and right now sunrise is scheduled to take place at 3:05 a.m. Pacific time here in Hawthorne. So in just about 21 minutes from now. So we're going to see Dragon slowly get closer now to the robotic arm. It's going to kind of park there, and then it'll be all the motion will be on the robotic arm side. We'll probably wait and see for those better lighting conditions, just to make sure they have everything lined up correctly with the robotic arm and that capture point on Dragon. And then it'll be time to grab it. So we're in motion again. We're getting a lot closer now to that capture.
Everything is slow and steady at this point. No reason to rush. I want to make sure everything is happening as safely and as controlled as possible, so that Dragon is going to just ever so slowly inch its way towards the ISS, probably for the next 15 or so minutes. And then, like Dan was saying, we do want to wait until we have a little bit more daylight in order to get the grapple fixture of the cannon arm closer to the grapple point on the Dragon.
So
that's going to be probably, well,
we do see the circle
3:05.
offset from a corridor center
So
by
we're
about
just
half
watching
of
that Dragon
vehicle
get
width
a little bit slower,
forward.
or a little bit
Other than
closer.
that, the vehicle size is relative to the outline.
All right, so as it goes on this final approach, yeah, let's listen in.
All right, copy that, Serena. That's a good report. Station Houston on Space to Ground 2 for Dragon.
1, 2.
Okay, Serena, we had a failure here on the ground that's going to impact our next scheduled communications path. We're working on filling that gap, and I just want to give you a heads up now. So in 10 minutes, we're going to go ahead and call you back and give you a status of where that's split up.
Copy, Houston. Houston Station on 2 for Block Bravo. Everything looks pretty centered up on both monitors.
Copy and concur, thank you. Station Houston on Space to Ground 2 for Dragon.
On 2.
Okay, Serena, got a couple things here. We're going to confirm the capture point hold for step 6 in 1.102. And with respect to that ground failure I told you about, we're still working it, and I'll get you a status here in the next couple minutes.
Copy, we'll proceed with step 6 and then waiting to hear your words.
All right, and we just heard the call up to Serena on Chancellor. Dragon is at the capture point. So right now it's just 10 meters away from the space station, just about 30 feet. And you can see just how close it is now to that space station robotic arm. As you heard the Capcom say, though, they are working a ground issue before they give the crew the go to actually reach out and grapple the Dragon. So we will stand by for a couple of minutes and get some more details on this. But we are at this final hold point. Dragon's not going to get any closer until it's within the grasp of the Canadarm to robotic arm.
We are close enough that you can see this is a shot from the International Space Station looking at the end of that Canadarm and the Dragon. Beautiful shot. You can see exactly how close we are to the end of that grapple point. As soon as the station crew gets the okay to proceed, Dragon's actually not going to move. It'll stay right at that 10-meter hold point, but the robotic arm will now move closer to Dragon. And you can see the grapple
Houston
point
Station on 2.
right on Dragon
Capture
right there.
conditions
Let's listen in.
confirmed and crew ready for Dragon capture.
And Houston, copy. Standby 1.
And so that real quick was just Serena confirming the crew is configured and they're ready to go. So now it's just the teams over there in Mission Control Houston working this ground issue. And then once that gets figured out, they'll give the go to the crew to actually reach out and capture Dragon. Again, we have a capture window, so this isn't all timed to a very specific second or minute. They have a window where the lighting conditions will line up and they can actually reach out and grab the Dragon spacecraft.
And Station Houston on Space to Ground 2 for Dragon.
For Dragon.
Okay, Serena, given our comm conditions now, we're going to ask you to command a retreat to 30 meters.
Copy. Commanding retreat to 30 meters.
And Station Houston on 2, due to the failure on the ground here, we will be losing our next compass, and we will be back with you at around 11:50.
Copy on the comm and 11:50. Houston Station on 2, retreat command issued.
Houston copies.
All right, well, right now you're going to see Dragon slowly start to fly away now. So the crew just sent a command to Dragon to depart from this 10-meter point back to the 30-meter while the teams down on the ground continue to work that communications issue. So Dragon got to that capture point, but they're still working an issue on the ground with communications with the space station. So while they continue to work that issue, they just have the crew give the command to send Dragon back to the 30-meter point, where it's going to hang out for a little while they continue to work this issue on the ground.
As we said before, this really is a slow and steady wins the race kind of event. Dragon has power from its solar panels and has batteries on board and is totally cool hanging out until the station is ready to grapple it. And of course, the timeline is very flexible for these kind of events. We don't want to approach a station until everything is in perfect order. So right now that Dragon's going to retreat back to its 30-meter hold and just hang out there until both the teams on the ground and the station can get everything taken care of.
Yep, and you heard him tell Serena on board the space station that they would be back with her at about 11:50. So the space station's running on GMT, Greenwich Mean Time. So that's 11:50 that time. That's about 45 minutes from now. So we'll continue to hang out here and wait for any updates on the issue being worked down on the ground and see what's up next for Dragon.
Station Houston on Space to Ground 2 for Dragon.
We are with you on 2.
Okay, Alex, before we went LOS, we saw a good retreat command, and SpaceX reported a good 30-meter hold. Our intention right now is to go ahead and circle the wagons, take a look at the data, and get right back with you. But fundamentally what we're going to do is look to depart to the capture point here soon, so stand by.
Copy all and standing by.
All right, and we're back. If you're still hanging here with us, we did get that communication back with the International Space Station. It took a little while. They've been working with the ground issue, but as you just heard that conversation between the Capcom in Houston and Alex Gerst on board the space station, we're back. There's Dragon, 30 meters away from the space station. We were there a little bit earlier, but we're back there now. Right now, the teams are doing a go, no-go poll. They're going to try to move through real quickly to get Dragon back into that capture point to try and capture it finally with this robotic arm.
All is good with Dragon right now. Like we said earlier, Dragon has its solar arrays extended and is capable of just hanging out until the crew on the ISS is ready to grapple it. When given the command, it'll go back to that 10-meter capture hold. And then if we're lucky, it'll proceed into a free drift state and accept the grapple. That'll be hopefully contingent on the crew giving us the okay soon.
Station Houston on Space to Ground 2 for Dragon approach.
Go ahead.
All right, Alex, we took a look at the data. We're comfortable. Dragon's ready to proceed to the capture point, so expect approach to resume shortly.
You copy all, and we're monitoring the upcoming approach.
All right, everything's sounding like it's good for Dragon to once again inch its way toward that 10-meter capture point. So we should see it start to move forward any moment now. The teams work through real quickly once they reacquire that communication with the station, syncing up with the crew. The teams here at Hawthorne working with the teams again out at Houston. And I think we're hearing now that Dragon is about to approach.
Space to Ground 2 for Dragon.
Go for Dragon.
Okay, Serena, Dragon has begun the approach from 30 meters. Monitor for step 5 and 1.102.
Copy step 5.
You heard that Dragon has been given the go-ahead to approach again to 10 meters. Dragon and the International Space Station are currently over Ukraine. However, it looks like it's a little bit cloudy down on the Earth, so we're not seeing too many land features there. But still a beautiful view of the Dragon as it holds, or as it begins its approach from 30 meters to 10 meters for its eventual grapple.
That's right, this 10-meter point, that's the final kind of checkpoint gateway that we'll see today. And then Dragon's done moving, and it's time for the robotic arm to spring into action. It's going to be Alex Gerst. He's the commander on board the space station. He's the one at the controls. You're going to hear Serena Chancellor, a NASA astronaut on board. She's backing him up, and she's going to be relaying kind of status updates as Dragon makes this final approach to the teams down in Houston. And then once it arrives again at that 10-meter hold point, it'll go into its free drift, and then it'll be over to Alex to control that arm to reach out and capture Dragon.
You can see on the right-hand side of your screen that is a camera at the end of the Canadarm, that 57-foot robotic arm that extends out from the station. And as Dragon gets closer and closer, we'll see it grow larger in that frame of view. And then when the Dragon stops, it'll be up to the arm to move into that capture point. You can actually see, this is a great shot right here. It shows just how close we are to capture. This is from another point on the International Space Station looking towards the Dragon and that arm. And it may be tough to distinguish the movement of the Dragon apart from the rotation of the Earth underneath it, but it is moving right now. Like we've said many times during this webcast, slow and steady wins the race here.
With you on 2.
Okay, the views on monitor 1 and 3 are the same. Everything is pretty much centered up except the vehicle is about, and the strobe is about half a width forward.
Okay, copy all. Thanks, Serena.
And for those that have been following along, this is a camera actually inside the International Space Station pointing at the screen that the crew is using to monitor Dragon's approach. So this is exactly what the crew is looking at this very moment. And there's a number of overlays on it. You'll hear them talk about things being about half a width out. You can see kind of an outline of Dragon. As it does this approach, it usually won't be exactly inside of there. They have a kind of a range that they're looking for Dragon to be around. And as you heard Serena on Chancellor radio down, it's about half a width outside there. But the team's expecting that, and everything's still good with Dragon's approach. And as soon as we reestablished that communication, they did work really quickly to get through the paces and get Dragon moving once again. We are coming up on a sunset in just about 8 minutes or so. So once again, lighting conditions will kind of come into play. But as long as everything proceeds smoothly, we should be moving in on a capture and not have to wait for another lighting condition. But it could happen. And again, Dragon can definitely just kind of hold out. As we've said over and over, and Tom just said again, slow and steady is going to win the race today. We're going to get this Dragon captured and attached to the space station with all 5,600 pounds of cargo on board.
As we approach that sunset, Dragon is free to approach right now to the 10-meter hold, and that isn't exactly dependent on the sunlight conditions, but the grapple action is dependent on the sunlight conditions. The crew at the International Space Station is only going to grapple it if it's freely visible inside the sun, and right now we are rapidly approaching that sunset. You can actually see the Earth darkening underneath on this view right here. Approaching that Terminator line.
Yeah, and the station and Dragon just flying just to the north of Kazakhstan. They're actually just a couple hundred miles to the northwest of Baikonur. Anyone who follows the space station, that's where a lot of launches come out of. And actually, the first piece of the space station launched just a little over 20 years ago. But they are over that Terminator line, as Tom was talking about, the Earth being shrouded in nighttime beneath now, as they are a couple hundred miles up in the air, though, about 253 statute miles right now. So it'll take a little bit longer for the sun to set on Dragon and the station than it does on planet Earth. But Dragon still continuing in towards that 10-meter capture point.
These lighting conditions are actually sometimes what helps you to see it from the ground is when it's dark where you are on the surface of the Earth, but the station is still lit up by the sunlight.
And just to recap what's still ahead, true, unless they, again, work really quickly to get that open. But once the hatches are opened, it kicks off a couple of weeks of really intense activity for the crew on board the station, which right now is at a full 6 crew members, with the arrival of 3 a little bit earlier this week. And there's a lot of science packed on board Dragon, about 2,200 pounds, so over a ton, that they're going to have to unload, and then they're going to execute a lot of those experiments while Dragon's still attached to the space station, because it then gets loaded back on and then delivered right back down to planet Earth. So there's really not a lot of time for other activities. Anytime a Dragon arrives, it's all science pretty much all the time.
And in addition to those supplies and science on the inside of the Dragon module, there are those 2 really exciting experiments that are in the trunk, the unpressurized cargo portion. And of course, along with those preparations that happen as soon as the Dragon's finished berthing, the Canadarm will be used to again go and pick up those experiments out from the back of the trunk and then mount them to their respective places on the outside of the space station.
Yeah, those operations will typically take a couple of days, and those are all controlled by the ground. So these are people sitting in a control room controlling a giant robotic arm 250 miles above their heads, pulling science experiments out of a spacecraft. I mean, it's really cool to think about. But it'll take a couple of days to pull both of those out, both the JEDI, and I always have to look at this one, the Global Ecosystem Dynamics Investigation, and I'm not as on my acronym game as Tom has been today. But they'll be pulling out JEDI and the robotic refueling mission number 3. This is the third phase of that experiment to be taking place on the outside of the International Space Station, testing a lot of technologies to refuel spacecraft and satellites while they're in space, even those that were never designed to be refueled before. So really exciting research being done, really cool technology demonstration.
Round 2 for Dragon Gopher capture windows.
And it sounds like we're getting an update on our capture windows coming up for the crew.
Houston, we are ready.
Okay, Serena, our intention here is to get you guys a Gopher capture no earlier than 12:18. However, that window expires at 12:23, so we've got a 5-minute window there for Gopher capture. And if we don't make that window, then we're going to hold at the capture point, and then the next window opens for Gopher capture at 12:39.
Copy 12:18 to 12:23, and the next window after that, 12:39.
It's a good readback.
All right, so those times that you just heard relayed up to Serena on Chancellor. So the International Space Station operates in Greenwich Mean Time. When you have control centers all around the globe and the space station circling the globe, we had to basically come up with what time zone are we in, and everybody had to stick to it. So we settled on one time zone, Greenwich Mean Time, GMT, and so those are the times you're hearing relayed up. So with that capture window being given as 12:18, it's just a little after 1200 right now, so that's coming in about 15 minutes from now. They'll have to have Dragon at that capture point and everything ready to go with the crew and the arm to kind of hit that last-minute lighting window. If they're not able to do that, they'll just kind of stand down for about 15 minutes or so, and then at 12:39 GMT, so in about 35 minutes from now, they'll get the go again to reach out and capture the Dragon.
Even though the Dragon and the International Space Station are currently over a darkened part of the Earth, which you can see in the background, they are still illuminated, being 400 kilometers up. This is still giving us enough light to work with, hopefully, here. It also gives you enough light to see the features on that Dragon, and when we get a direct-on shot from the Canadarm, you can even see the grapple point straight ahead, right in the middle of the Dragon spacecraft. That Dragon just continues to get closer to the ISS cameras, filling up more and more of the view. Dan and I have been now watching the Dragon for the ISS and the Dragon for a few orbits. We've seen it cover almost all the major continents on the globe. Right now, they're currently flying over northern China.
Dragon getting really close now to this 10-meter point. This will be the second time around, but last time they had to back off while they worked a ground issue with, you heard it called TDRS a lot. That's the Tracking and Data Relay Satellites. That's how we actually have communication with the International Space Station, and they had an issue with those systems on the ground that eventually got resolved. And as you can see, we're back in communication with the space station, obviously, as we're getting this live video down. But everything, again, continuing to progress smoothly. This another peek inside the interior of the space station, looking over the crew's shoulder at the monitor that they're using to watch Dragon during this final approach. And as soon as it hits that 10-meter point, it'll be over to the crew to get the go to capture, reaching out with that robotic arm, fixing to the grapple fixture, and then we are just about at that capture point.
This is the second approach of the Dragon tonight, but it is not the first time this Dragon has visited the International Space Station. As we said before, this is a reused Dragon spacecraft. First flew in the CRS-10 mission back in February of 2017.
So yeah, Dragon getting closer and closer. This is a camera view we're going to see a lot of, and especially as that arm starts moving in, because this is a camera sitting right on the end of the space station's robotic arm. That robotic arm called the Canada Arm 2, and this is sitting right on top of what's known as the LEE, and that's an acronym that stands for the Latching End Effector. That's essentially the hand of the space station's robotic arm. It's used not only to hold the robotic arm, there's one on either side of it. So one end right now holding itself to the International Space Station, the other going to be used to grapple with that Dragon spacecraft. This arm, very versatile, used for a whole bunch of different operations, not only just capturing spacecraft, but also flying spacewalking astronauts around, and was used to build the International Space Station piece by piece. So it's under the control of astronauts on board right now, who got it into its current position just a little while ago when we started all of these final rendezvous procedures. And it's going to be Alex Gerst inside, the current station commander, who's going to be controlling this arm, driving it in and capturing Dragon out of the sky.
That end effector is going to be mating with the grapple point on the Dragon, and you can see that that is on the inside of that GNC, or guidance, navigation, and control door. For launch and re-entry, that door is normally closed, flipped around, and sealed up. On the outside is the same thermal protection system material that we have on the outside of the Dragon that helps protect it from the atmosphere and from that re-entry heating. And the reason that the grapple point is on the inside is because it's not a perfect aerodynamic surface, and because it's a sensitive thing that the ISS needs to grab onto, we want to protect it during ascent and then re-entry. So it's tucked away on the inside.
Station Houston on Space to Ground 2 for Dragon.
Go for Dragon.
Okay, confirm capture point hold for step 6 in 1.102.
Copy step 6 and work.
All right, so Dragon is at that capture point once more. This kind of feels familiar, Tom, but it is sitting 10 meters away from the International Space Station right now. So what the teams are going to do is quickly do their go, no-go polls again, making sure that everything's good on the station side and on the Dragon systems to give the crew the go to actually reach out now with that station robotic arm and capture the Dragon.
Houston Station on 2, capture conditions confirmed and crew ready for Dragon capture.
And Station Houston on Space to Ground 2, you are go for the capture sequence. Perform step 4 in 1.110, Dragon capture. Begin monitoring the back away cue card.
All right.
Houston, copy, go for capture. Just clarifying, we thought 12:18 would be the time of the opening window.
Yeah, we were more efficient than planned, Serena.
Copy that, Houston, go for capture.
All right, well, those are exactly the words we wanted to use. Everything is now go for capture. So the crew's going to start working through some final steps, and any moment now we're going to start seeing that robotic arm in motion. So now we're just moments away. So it took a little while to get here. We overcame a couple of issues with our ground communications, but now we're here. Dragon's just 10 meters away, and it's time to capture.
We heard more efficient than expected. That sounds great to me.
Always good to hear.
Dragon is now filling up most of the view of those cameras, especially the one on the end of the Canadarm. We're going to see it get very close to that grapple point on the GNC bay door. As we mentioned earlier, at this point, Dragon's actually not doing any more moving. It is holding at the 10 meters point, and from now on, it is the station crew moving the Canadarm towards the Dragon.
That's right. They're gonna close in. It's a very, just like everything else so far, it's a very slow and methodical process to drive that Canadarm in. And once it makes that initial contact, it'll get kind of a light hold on it, and then a series of snares will draw that grapple fixture all the way into the robotic arm, giving them a tight hold on the spacecraft, at which point the crew is done with their activity for now, and they hand over to the ground to actually maneuver Dragon using that robotic arm and attach it to the Earth-facing side of the space station on the Harmony module, also known as Node 2.
Now, my experience has mostly been with the Dragon spacecraft approaching the International Space Station, but Dan, I imagine you've seen a lot of vehicles visit the ISS and have a lot of experience seeing not only Dragons, but Soyuz, Progress, all the visiting vehicle family of the International Space Station come to dock and berth.
Yeah, and it's always interesting because they all kind of have their own little differences between how they do that. Obviously, with today, being a berthing, so you have the grapple portion of it, whereas with like a Soyuz or a Progress, it's all a docking and they just kind of drive straight in. I typically tend to prefer those personally just because they're usually a little bit quicker. But I mean, they're always interesting operations. Like, it's still space flight, it's still crazy stuff happening 250 miles above us. But it's always fun to see a vehicle arrive at the space station. It always means a flurry of activity, both before, during, and after. So especially with Dragon here now for the crew, they're going to be really busy. And there's going to be a bunch of new science experiments that they're going to bring off and work on. And those are always interesting to track along, working on all these different disciplines, from monitoring the Earth below us to doing new research on drug breakthroughs and things of that nature as part of the U.S. National Labs. So yes, it's always interesting to see a vehicle get there just because of all of the other kind of the cascade of events that it always brings with it.
It is pretty cool that we have this international laboratory that has so many different types of vehicles coming to visit. It really kind of shows how much of a collaborative effort it is between all the nations of the Earth and the ones that are involved in the International Space Station. Everyone kind of pulling their weight and to bring up science and humans to and from. It's pretty cool.
Traffic's been busy too. I think this is about the 4th vehicle to arrive at the space station within the last couple of weeks. We had a Cygnus a little while ago, a Russian Progress vehicle, a Russian Soyuz spacecraft just earlier this week arrived on Monday, and now a Dragon. So it kind of feels like the end of the year. We're getting towards the holidays, but nope. The traffic always picks up for the space station.
All the kids are coming home.
Yeah, everyone's coming home. And this isn't even the end of the year. This isn't even the last kind of big thing for the year. So Dragon's going to attach, and then 3 of these crew members are coming home in just about 12 days. 3 of them, including Alex Gerst and Serena Anand-Chancellor, who are doing this activity. They're actually scheduled to land along with Sergei Prokopyev coming up on December 20th. So for them, it's going to be a heck of an end to their mission. They've been on board the space station since June earlier this year, so wrapping up about 6 months for them. They were originally scheduled to come home a little bit earlier, but everything got kind of rescheduled with the Soyuz flight schedule. But yeah, this will be kind of the last thing capping off their time on board the space station. This was Serena's first flight, and this was actually the second for Alex Gerst. But we're almost at that capture. That station robotic arm going to slowly start maneuvering in. Again, it's Alex Gerst at the controls. He's using, it's kind of like video game controls. It's a joystick and a hand controller inside the space station. So he's going to be driving in, Serena Anand-Chancellor backing him up, making sure everything looks good with all their measurements and their camera views on Dragon, and also doing the voice comms with the ground. But you can see it ever so slightly getting closer now.
That view from the cupola must be unbelievable. I don't know how I'd be able to get anything done with a view like that on my window.
Every single one of them says, you ask them what do they do with their free time, and they go just spend time looking out the window. If you've ever seen any video from the space station or any of the really crazy time lapses they've done of planet Earth, pretty much all of those get taken from that cupola module. And it's this big 360-degree bay window that we use for a lot of Earth observations, but it also provides a wonderful vantage point for operations like this. It's basically, it's right near the docking port or the berthing port where Dragon's ultimately destined for, and it provides a stellar view of all of the operations of these arriving spacecraft.
It's got to be one of the biggest windows ever flown in space on that cupola or something similar to that. It's
definitely up there. It's larger than any other window on the International Space Station. It's actually a series of a bunch of different window panes, all in one kind of small module. Any Star Wars fans out there, it looks kind of like the window on a TIE fighter, if you will, and it provides this 360-degree panoramic view of the Earth below, and also spacecraft. But for now, we're getting closer. We're just a couple of meters away now. You can see that grapple fixture right in the center of the crosshairs now, and this is a view from the end of that station robotic arm.
We are actually close enough now that you can see the movement of the Canadarm. Too slow or too far away to see the slow movements before, but we are definitely approaching that grapple point.
And hearing we're less than a meter away.
You can see on the left how far that arm has come. It's right up against the side of the Dragon now.
All right, we're going to stand by for that initial capture. Here we have a good alignment. And the capture's been commanded. All right, and that is a capture. Capture coming at 4:21 a.m. Pacific time. 6:21 a.m. over in Houston. That's where my computer's time is set to, but that capture is confirmed. Again, 4:21 a.m. Pacific time, with the space station flying 250 statute miles to the north of Papua New Guinea, just out over the Pacific Ocean. We got it. We got it.
Finally, we did it.
But so again, Dragon's captured. We'll stand by for a little bit. Usually the crew likes to offer some words, but they were able to do that successfully. Once they recovered from that ground communication issue, the teams got through all their procedures real quick, and now Dragon within the grasp of the Canadarm2 and just one step closer to being attached to the International Space Station. And now that they have that kind of initial grasp, oh wow, that's actually spectacular. So that is a thunderstorm down on planet Earth that we're seeing flash there in the background. That's not something you see every day.
I was going to say, that's pretty spectacular. Definitely worth waiting for, right?
And hearing confirmation, the snare is now retracted all of the way. Dragon firmly in the grasp of that Canadarm2.
This has been an end to it's been an exciting journey for the Dragon spacecraft. It launched from Cape Canaveral back on Wednesday morning, and is finally now completing its outbound journey to the International Space Station. And like we said before, this is the second time this Dragon has made its way to the ISS.
Houston Station on 2, we have confirmed capture. The arm is safe, and the International Space Station Expedition 57 crew would like to congratulate NASA, SpaceX, and the international partners for a successful launch and capture of the 16th SpaceX Dragon cargo resupply mission, enabling the ISS program to continue performing its science program on this unique laboratory in Earth orbit. Also, we congratulate the entire ISS team for managing 6 individual spaceships that will be simultaneously docked to the International Space Station from today on. This shows what a successful science and exploration program we have up here, making full use of the one and only microgravity laboratory that humanity has available for the benefit of all humans on planet Earth.
Yeah, Houston copies and concurs. Thank you, Alex.
All right, so some great words from Alex Gers, who just executed that capture. Again, that capture coming at 4:21 a.m. Pacific time, 7:21 a.m. for anyone watching over on the East Coast. But Dragon now in the hands of the crew on board the International Space Station. Well, on behalf of SpaceX and NASA, I want to thank everybody for tuning in, either staying up late or waking up early for today's webcast. Now that Dragon's reached the International Space Station, it's set to return in January. But first, the spacecraft has to get bolted onto the station, and the hatch gets opened. And that'll happen a little bit later, and you can go head over to NASA TV to watch that berthing operation.
Thanks again for watching. Thanks, Dan, for joining us here at SpaceX headquarters.
Thanks for letting me crash.
Oh, no problem. Please be sure to follow SpaceX and NASA on social media for updates on the CRS-16 mission currently in progress. Thank you so much for watching, and have a great night or morning.